Hello everyone, welcome to this session on Introductory Scientific Computing with Python. In this session, I will be talking to you about what Python is and why we should use Python. My name is Prabhu Ramachandran. I teach at the Department of Aerospace Engineering at IIT Bombay, and I have been using Python for close to 2 decades. Before we begin, I would like to acknowledge the FOSSEE group based out of IIT Bombay, and this project has been receiving funding through the National Mission on Education through ICT, and this program is being recorded under the FOSSEE group. So the first question we look at is why Python? Specifically, why Python for scientific computing? And in this session, what I'd like to do is try to motivate you why we need to use Python. So when we as scientists do any research work, there are several things we need to look at. It's not always just pure computing that we're interested in. We often need to look at numeric and symbolic computation. And then when you're looking at data that you generate, you often need to explore and visualize that data. In addition, you also need to do high performance computing, parallel computing, and often your tasks aren't just restricted to these. You also want to create sometimes a user interface. You may want to create a website, or you may want to create a web-based application. For all of these, you need one powerful tool with which you can create applications, explore your data, do your numerics, do your high performance computing, and a variety of other tasks that come up. So what we are looking for is, we are looking for a very general purpose tool that can help us do this. So why do we need Python? Well, so Python is a programming language that's very easy to read and learn. This makes it easy for people to quickly pick up the language. It provides you a very powerful interactive interpreter. This is similar to many other interactive systems, and for a lot of scientists it's very important to be able to interactively explore your data. So the fact that it has a powerful interactive interpreter is a very important factor for scientists and engineers. Python is also very scalable, so you can not only write small little scripts to do things, you can also write full-fledged applications, and I'll show you quickly a few demonstrations of these. It's also very high level, so it's not a low level language like C or Fortran. It's high level, which means with a very few number of lines of code you can achieve a lot. It also is modular, which means you can compose your programs using small elements, which is a good style of programming. And unlike certain languages, it doesn't force upon you programming paradigms. You can write it either procedural, object oriented, or functional, and that's up to you. In addition to the basic features as a programming language, Python stands out simply because it has extensive libraries, and this facilitates rapid application development. So you can interface Python code to C++, C and Fortran codes. It's cross-platform and open source, and this makes it an extremely powerful tool that allows us to do all of those requirements that we talked about very easily and very conveniently, and it's completely free, so you can use it without any licensing. So let's look at the requirements. So if you look at numeric computation, typically this is what you have. So you have something like a terminal where you're typing code and you want to interactively explore your data. So for example, here are plots that are produced using Python. So there's a library called SciPy, which supports a variety of traditional numerical computing like linear algebra, numerical integration, Fourier transform, signal processing, special functions, statistics, optimization, image processing, ordinary differential equation solvers, and underneath SciPy uses well established libraries like LAPACK, QuadPack, ODEPack, FFTPack. All of these are well established libraries written either in Fortran or in C, and SciPy exports all of these into a Pythonic interface that's very easy to use. So this makes it very easy for scientists to do their numerical analysis. Now it's not enough if you just generate numbers, you also want to be able to visualize these numbers. So if you look at this picture, we have a terminal here where we have typed out some code, and you can see that with like 3 lines of code you are able to create a visualization like this, and this is a 3D interactive visualization, and all of this, the application itself is written in Python. The analysis is also doable using Python. So this shows you the breadth of things that you can do with Python. The same 3-dimensional visualization tool also has a full-fledged application. As you can see here, you have a nice UI that you can click and use, and you have a visualization along with an embedded Python interactor. So all of this can be done with Python. This entire application is written with pure Python. Now as I do my research, for example in aerospace engineering, I need to do a lot of computation. and this requires a lot of high performance computing, and it's often in parallel. So a lot of my codes are all implemented at a high level in Python. Underneath they might be calling to C or C++ or Fortran libraries, but you can simulate things like this. So here's a dam of water here, and there's an obstacle that you see here, and the water essentially is flowing past this, as you can see in the second screenshot. So these kind of computations again can be performed through Python. So it's an extremely powerful tool that facilitates a lot of scientific computing. As I said, it's not all the time that you need to do computing. Sometimes you need to produce an application. So here, for example, is a screenshot of a application built using WX-Python, which is a GUI toolkit. That's a graphical user interface toolkit, and you can see the kind of complicated UIs that you can build using Python. And again, this is written in Python. Here's another very simple example of code which basically demonstrate these lines of code. 1, 2, 3, 4, about 6 lines of code. If you run this, you will get either this kind of a user interface if you're using Qt, or with WX-Python you'll get a user interface that looks like this. And this shows you that with a very small amount of code, you're actually able to create a user interface. This is again a very powerful feature that Python with a small amount of code lets you achieve a lot. Now apart from desktop applications, you also want to create web applications. So there are many frameworks in Python that are called web frameworks. Basically these allow you to host a web application on a web server. Django is one of these. It's probably the most popular of these, and with Django you can build full-fledged websites as well as web applications, and that is also completely written in Python. Then again, let's step back. How about the language itself? So let's look at a small simple example for the quicksort. It turns out that these 6 lines of code are essentially the quicksort implementation in Python. As you can see, quicksort is not a simple algorithm, but what you see here is with these 6 lines you succinctly capture the essence of a quicksort, and not only is it the essence, it's not pseudocode, it's real code. If you run this, it will actually work and help you sort elements using the quicksort algorithm. So as you can see, this code is very readable, very simple, and still very compact. It succinctly captures the intention of what you want to program. This is again a very important feature of Python. In fact, probably one of the most important features of Python, because if anybody writes the code in Python, usually you will be able to read that code and follow what's going on. All this is very nice, but who actually uses Python? Well, it turns out that pretty much everybody you think about uses Python. All the big names that you've heard, Google, Yahoo, Facebook, IBM, even people who make movies, all of these people use Python heavily inside. So what we are trying to say is there are diverse needs that a user has, and the user does not necessarily have to be a computer scientist. Very often even scientists and engineers need a lot of things that need to be done on a computer. And for this we believe that there is one language that really helps you do all of these. So learning one language allows you to do a lot, and we believe that's why you should learn Python. Thank you.